Okay, so we have our parent function. For some reason, our parent function is labeled y instead of f of x. That's a mistake. It should be f of x. So number one should be f of x plus 1. That means go up 1. I'm going to use this guy here to talk about number 2. So what's happening in what's happening in number 2? Reflecting over the x-axis. Left 2? Right 2? Down 2. So if it's outside the parentheses, that's the y direction. The later ones here, let's see, this, inside the parentheses, this is going to be our left one. Okay, so when we go vertical flip, oops, and down 2, oh my gosh, maybe this is not good. Okay. The order that you do that in doesn't matter, sort of. So if I flip this and then go down 2, that's our answer right there. Or if I go down 2 first, that's fine to do the down 2 first, but I should not flip it over the x-axis now. I should flip it over this basically new x-axis that we created. We should just flip it right over itself. So you can do it in that order as well. This is how we've done most of our transformations this year. And so just flip over itself. So the order doesn't matter as long as you're flipping over the new x-axis. Do you guys understand the difference between those things? See what I'm saying? If this were flipped over the actual x-axis after the shift, it would be like here to there, and then to this, which would not be the right answer in this case. Mike?
So, from my understanding, everything that happens on the outside of f of x affects the y value, and everything that happens inside of f of x affects the x value.
Couldn't have said it better myself. Yep.
But like everything in the f of x is the opposite.
Yes. Yeah. Everything that happens to x goes like in reverse. Yep. Because, yeah, and another way to think of that is f of x, what other letter do we use instead of f of x? We use y, usually. Yeah, I mean g of x, yes, you're right. But f of x and y are the same thing. So this basically saying negative y minus 2. Whereas all the stuff in parentheses is happening to x and not y. Yep. Okay, so our final answer for that one should be this. Okay. So number 3, what's happening with that one? Stretching, which way, vertically or horizontally? Vertically. So it's on the outside, it's happening to y. This is like saying 2 times y. So instead of going up 3 to start, we're going to go up 6 to start. Oops. Like that. That point that's on the x-axis, when that gets stretched, it's still at 0. This little point here that was going down 3 is now going to go down 6. Like so. And so similarly, number 4, what's going to happen? Compress, yeah, vertical compression. And so one thing to think about, if there was a shift happening too with this, it's not just the y coordinates that we're multiplying. What we're really looking at is the vertical distance from the x-axis. So like this vertical distance is 3 for all these points. This one is also 3, just going the other way. So if we were going to shift it and compress, we would want to make sure our vertical distance was getting compressed, not just the numbers for the y coordinates. So instead of vertical distance of 3, it's now going to be 1. Same for this point. That point's still going to stay at 0. Questions on those? All right, as we mentioned, this one is going left 1. So that's just here. Like that. F of negative x, what is that doing?
Flop it.
Flop it horizontally, yes, or flip it horizontally, yes, yeah. Horizontal reflection, if there's no shift, it is over the y-axis. If we shift, it's not necessarily over the y-axis. But yes, it's going to go like this. F of x minus 3 in parentheses is going which way? Right 3. All right, and then the last one. What's happening with that one? What's up? What? Okay, y values are going to change yet? Specifically. Yeah. Vertical flip, vertical compression, down 1. Again, the order of this doesn't matter. If I go down 1 first, which I like to do, I just need to make sure that my vertical distance is affected. So normally I would be going up 3 to start, right? So now I need to go which way and how much? Down. How much?
Like 1.5.
Yeah, 1.5, exactly. So instead of going up 3, we're going down 1.5. There was a point over here that was down 3, right? That's where that little pointy boy is. So now we'd be going up 1.5. And this one still stays on the x-axis. So again, that compression is affecting our vertical distance. Right now that's 1.5 right here. I'm reflecting over the place where I moved the x-axis to. Okay, questions on any of that? Okay, so this is the same idea of graphing that we've had all year. That if we know the parent function, whatever parent function we're talking about, and we know what all the shifts mean, we can basically graph anything without too much difficulty. So here's a bunch of parent functions that we're going to go through pretty quickly. And then we're going to do a bunch of shifts with them, but all the rules are the same. Okay, so we've got our x squared, our parabola here. Fun fact about x squared, it's an even function. We've got x cubed. So 1 cubed is 1, 2 cubed is 8. So that's like off the graph. Negative 1 cubed is negative 1. Negative 2 cubed is negative 8. Fun fact about that one, that's an odd function. We've got our square root x, so square root of 0 is 0, square root of 1 is 1. What's another x value I could plug in that would be a perfect square? 4, right? So x squared of 4 is 2. Numbers 1 and 3, are they inverses of each other? Are they inverses of each other? No, they're not. Why not?
Because it's only half of it.
Okay, it's only half of it. Yeah, they have different shapes. So these are not inverses of each other, but half of this is an inverse of half of this. Or sorry, all of this is an inverse of half of that. If we want it to be the real inverse, it would need to be plus or minus square root x. But for the positive part of it, the x's and y's switch for that part of the problem. What about 2 and 4? Are they inverses of each other?
Yes.
Yes, they are. Yes, they are. Cube and cube root are inverses of each other, so the x's and y's are going to switch. Notice they have those same 3 points, but instead of going 2, 8, I'm going to go 8, 2. That's like way over there. Also notice our domain of this, it's a cube root, so it's all real numbers. Whereas the one before, square root, notice there's no negative x's in that part of the graph. Okay. 1 over x, we've graphed some more complicated versions of this earlier this year, but let's remember a few things. So domain restrictions, what can x not equal? 0, yeah. What are we going to have at 0? An asymptote, yes. We're going to have a vertical asymptote. Anytime we would divide by 0 in a graph, we have a vertical asymptote. So there's 2 numbers I can plug in for x that will give me whole numbers. 2 integers, 1 and -1. Yep. As I go to the left towards the y-axis, if I plug in like 1/2, 1/3, 1/4, 1/5, as I get closer to 0, what's the graph going to be doing? Yeah, it's going to be going up. So if it's 1/2, I would get 2. If it's 1/3, I would get 3. As I plug in 2, 3, 4, 5, 6, as I go to infinity, what are we approaching? 0, yeah. That number on the bottom, as it gets bigger, the overall value gets smaller. And we're going to have the negative version of that going on over here as well. So we've got our horizontal asymptote at 0. It's bottom heavy. Another way to tell that. There's no x-intercepts. There's no y-intercept. This function is also odd. If you rotate it 180 degrees, it would look the same. Okay, this next one is a little crazy looking. I'm going to zoom in. So this is an example of a step function. This is, I believe, the least integer function. It's also the least important one that we're looking at today, but we're still looking at it. So it's kind of crazy. It looks like this. So we've got a little pattern here of closed circle, open circle, horizontal line. Okay, so maybe you can see why it's called a step function, because it looks like steps. That's why. Kind of strange looking. What this function is going to do is going to, whatever x value you plug in, it's going to round down to the nearest integer. So if I plug in 1, the nearest integer is 1. But if I plug in 1.2, what's the y value going to be? 1. It's going to round down to the nearest integer. If I plug in 3.6, what's the y value? What? Round down to the nearest integer. So that's why we got these vertical lines, right? All that one right there is between 1 and 2. Everything is going to have a y value of 1. Okay, what about negative 1.2? It's going to be negative 2. It's rounding down to the nearest integer. The nearest integer below that value. So negative 3.6 would go to negative 4. Yeah, exactly. It's going down. Okay. So kind of strange looking. Notice the slope of the dots is 1. If it was like 2 bracket x, the dots would go, you know, like a slope of 2 from there. You would have 1 there, and then you would have 1 here, like that. Again, this is the least important one, so don't worry about it too much. Okay, absolute value x. It's that V shape. Also an even function. Plus. The slope of either side is 1 and negative 1 for the parent function, right? If it's 2 absolute value x, the slopes would be 2 and negative 2. Okay, and now we're getting into some review from earlier. We've already looked at these parent functions in quite a lot of detail. 2 to the x. We also did like 3 to the x, 4 to the x, etc. So what's 2 to the 0 power? 2 to the first power? 2 to the second power? 2 cubed. So we got our 1, 2, 4, 8 would be above. 2 to the negative 1? 1/2. 2 to the negative 2? 1/4. Okay. And closer on to 0 as we go. So we've got a horizontal asymptote. So this is the first parent function we did transformations with this year, back in the day. How are 2 to the x and log 2 of x related? They're inverses of each other, yes. Log 2 of x and 2 to the x are inverses of each other. So we switch the x and y coordinates. So we got our 1, 2, 4, 8 over here. Remember x, like the number inside the log, is the number that 2 turns into using exponents. And then the overall log is the exponent that does that. So what exponent turns 2 into 1? 0. What exponent turns 2 into 2? 1. What exponent turns 2 into 4? 2. What exponent turns 2 into 8? Okay, and so we see those x and y coordinates flipping like that. They're inverses too, so instead of a horizontal asymptote, we're going to get a vertical asymptote. So they are like reflections of each other, thusly. Okay, what is E? Huh? E is not 10. E is not -1. Okay, E is 2.71828, etc. E is a number. It's like pi. It goes on forever. It doesn't repeat. E represents 100% continuous exponential growth. So if you have $100 and you invest it into an account that gets 100% interest, compounded once for 1 year, 100% interest is ludicrous, right? You'd never get that. But how much money would you have at the end of 1 year? $200. You would get 100% growth. You would double your money. We looked at versions of this if you compound it 2 times. So basically, you compound it once, you get 50% interest. You'd have $150. Then you would compound it a second time. 50% of that is 75, so you'd end up with 225 total. So the more you compound, the more you end up with. If you compound continuously, this is standard 11, by the way. If you compound continuously, meaning it is constantly recalculating your interest, but also that 100% is divided sort of into infinite. It's like compounding an infinite number of times but divided into an infinite number of percentages. Do you know how much money you end up with at the end of a year? How much? You would end up with $271.83. It's that number times 100.
Oh.
Yeah. So that's what it represents. No. This is standard 11. So we already did this. A long time ago, but we did it. So in terms of the parent function, what is e to the 0 power? Yeah, e to the 0 power is 1. What is e to the first power? E. Yep. So that's like 2.71-ish. Put it on the graph. That's all we need for our parent function. You know, e squared is, I don't know, 6 point something or 5 point something. I don't know. It's between 4 and 9. I don't know. Those are the only numbers we need. But it works just like 3 to the x or 4 to the x or 2 to the x, except now it's 2.718 to the x. How are e to the x and natural log of x related to each other? They are inverses, yes. So natural log of x is the same thing as saying log base e. So just like 2 to the x and log 2 of x are inverses, e to the x and log base e are inverses. So we're just going to switch the x and y values. So instead of 0, 1, we've got 1, 0. And instead of 1, e, we have e, 1. And this is in the same family as log 2 of x, so it's got the same shape. There's a little review of our marriage functions. You are pretty much expected to know what all of these look like. Not necessarily have every detail of them memorized, but you should be able to figure out what x squared looks like, right? Because you know what 1, 2, 3 squared are, right? And negative 1, 2, and 3 squared. You know how to cube numbers, you know how to square root numbers, so. But if you're more of a visual learner, you know, you can start looking at some of the features of these graphs, some of the shapes. This one's got these nice 3 points right in the middle, so. Anyways. So next page, because basically what we're going to be doing is graphing these, doing all the same transformations we did on the first page. So I'm going to look at number 4 and 6 with you guys. And then you guys are going to do the rest.
Yeah.
So here's how we go. Number 4, our parent function is 1 over x. Which way is it shifting? To the left. To the left. To the left, to the left, to the left. We could also figure out the domain by looking at this, right? What number can x not equal? -4, right? We can't divide by 0. We don't even need the graph. But shifting this left 4, vertical asymptote goes down there. There's my point 1, 1. My point -1, -1. So my graph would look like this. So just that parent function moves to the left. Yep. We move the whole graph to the left. So like these 2 points, the asymptote, everything. Those are the same points from the parent function.
Wait, so the x is the opposite. So like the shifts are opposite with x.
Yes.
So it's just subtract 4 instead of adding 4 to the exponent.
Yes. Left. What's the range of this graph? Everything's 0. Nice. Okay. So again, if I know the parent function, I know those 2 points there. That's 1, 1, and -1, -1. Okay, number 6. Which way is our step function going? Right to, yeah. So even though this is kind of a weird looking function, instead of starting here, we would do that to the right 2. And we would have the same shape. Yeah, this is a better way to do it. What is the domain of this? All real numbers. What is the range? How can we describe the range?
There.
Negative infinity to infinity? Yeah. Maybe not. Let's figure out just using like normal words. Like how can we describe the numbers that are in the range? All integers. Yes, all integers. So that's, you know, -1, 0, 1, 2, 3, etc. -2. It's not all real numbers, right? Because -2.5 or 1.7, those are not in the range. It's all the integers. Okay. If we were going to say, there's a way to write all real numbers in interval notation, which is this. There's also a way to write all real numbers in set notation, which is this, x such that x is an element, that's an E, of the real numbers.
That's not great.
There's not really a way to write all integers in interval notation, the first one, but there is a way to write it in set notation. Looks very similar. X such that x is an element And instead of using the R, which represents real numbers, we're going to use the symbol for integers. Does anyone know what it is? It's not an I, because that represents imaginary. Okay. It is a Z. I didn't make it up. And it's a Z with the same font. It's an E. It's a little weird E. Okay.
Looks like Euro. That Z supposed to be.
Yep.
Wait, Mr. B, is that Z supposed to look normal?
It's supposed to look like the R. Same font.
Oh.
So like for natural numbers, that's natural numbers. For the complex numbers, it looks like that. So there's some other ones. For I think that's how it looks. Q is all the rational numbers. Anyways. Z is the integers. That's not the main. Oh, what's up? Okay. Again, that's not the main focus of this. The main focus is the transformations, manipulating the graphs, moving them around. That's what we want to focus on. But there's some fun math facts. Okay, you guys do the rest of the graphs on this page.
That's yikes.
Ready, set, go. All right, let's check this first page here. So number 1 to be our parabola going which way? Down. So down 1. There's 0, 1, 4. And we don't have enough room for 9, but in general, when you're graphing these, you want to put as many points on the graph as you can. So if there's room for the point, put the point on it. Domain? All real. And range? Negative 1 to infinity with a bracket. Okay, x cubed going which way? Up. Up 2. So there's my 0, my 1, my negative 1. Going to the right, I don't really have room for 8, but negative 2, negative 8. There, right? Yes. Domain and range. Alright, square root x going which way? To the right, yeah, so it's happening underneath the square root 2x. That's going to affect the x direction. We're going right to. Domain, we could do this one without looking at the graph. 2 to infinity. We could set x minus 2 greater than or equal to 0, right? Range is 0 to infinity. Brackets. Okay, question on those? All right, and then cube roots of x going which way? Left. Yeah, under the cube roots affecting x. So left 3. We get our up 2 to the right 8, right there. Domain and range, just like the inverse. The domain and range switch for 2 functions that are inverses. In this case, they were the same thing. Questions on that one? All right. Do the next 3 at the top of the page on the back. Getting a little bit harder, but still not too bad. All right, let's check these. So number 7, what's happening to our absolute value function?
No, y values multiplied by -2.
Yeah, y values multiplied by -2. So we're gonna have a flip and a vertical stretch. It's basically the slopes of those lines are going to be 2 now, so down 2 over 1. So just think of like 2 lines meeting, one's got a slope of +2, one's got a slope of -2. Domain is all real numbers, range is nice. Okay. This parabola here for number 8 is in vertex form. That's how you would have described it last year. It's also called transformation form. That's what we're doing transformations. So which way is our parabola going? Nice. Left 3, down 4. Okay. So then that's like it's 0, 0. So now I have 1, 1, 2, 4, 3, 9. And -1, 1, -2, 4, -3, 9. Again, we want to put as many points on the graph as will fit. Okay, for number 9, we could find a common denominator and put it together like this if we want. But we don't have to, and I probably wouldn't do that. I would just say, oh, that's my parent function shifted which way? Down. So down there, that would be right too. Next to it, it's going to be down 2. So there's my horizontal asymptote. Here's my vertical asymptote. There's my point 1, 1, and -1, -1. Combining it to get a common denominator, I could see like, oh, horizontal asymptote is at -2. I could see that. I could also get the x-intercept from that as well. But it's not necessary to do that. It just would work. X can't equal 0. Y doesn't equal -2. Okay. I want to look at 11, and I want to change number 12. So for number 11, there's kind of 2 ways to look at this. If I'm multiplying x by 2, what does that mean is happening? Expanding, horizontal stretch. It's actually a horizontal compression. Remember, x is backwards. So everything is 2 times as close to the origin. So that's one way to do it. But a horizontal compression, making a cube root graph skinnier, is the same as a vertical stretch. That's not the same for every type of graph. Like remember for sine and cosine, you could do a vertical stretch without compressing it horizontally. Those things were separate. But with polynomials, that's not the case. So, and the reason why is I could distribute that exponent. This becomes 8x cubed. And now, how would I describe the transformation? It's 8 on the outside of x. Yeah, this is a vertical stretch. So again, with a polynomial, they're the same thing. Everything is like 8 times as tall. So either way we think about it, we're going to get the same set of points here. 0, 0 is still going to be the case. In the parent function, what's 2 cubed? 8. So now, if I'm thinking of this as a horizontal compression, everything is twice as close. Instead of 2 8, it's going to be 1 8. So it's closer. The 8 value is closer to the origin. That's how we think about it in terms of the compression. But we can also think about it as a stretch, a vertical stretch. Because we would have the point 1, 1, but if we stretch that 1 by 8, where would it be? Stretch it by 8. Yeah, it's just going to be an 8. So either way, we get our point 1, 8. So 2 ways to think about that. This is really hard to draw and make it look like a cube. Really just looks like a line. I think that is easier to do. I think the vertical stretch is easier than the compression. Okay. Then, number 12, change number 12 to this. Negative x minus 3, all in parentheses. Okay, which way is x cubed going and what's happening to it? Staying negative?
Or, it's going.
So if the negative's in front of x, which way is it flipping?
Oh,
Up and down or side to side? Side to side. It's happening to x, it's happening in the x direction. This is a horizontal flip. Okay. Which way is it shifting? Hey.
right here.
No, it's not going right 3. It's actually going left 3, but it's kind of a trick question because what we need to do is, we've mentioned this a few times, we had to do this with sine and cosine. If there's a number next to x, in this case it's just -1, we need to factor it out before we can see what the real shift is. So remember with like sine of 2x minus pi, this one's going to the right actually pi over 2 because we need to factor that 2 out. Same thing here. That negative, or it could be a 2 or a 3 or whatever, needs to be factored out. Notice I can't take it all the way out of the cubed parentheses. I'm not allowed to do that, but I can factor out of this little expression. So any coefficient of x needs to be factored out. So left 3, and then it's shifting or flipping horizontally. Which in this case is the same thing as it flipping vertically, but that's just F. Okay. So a couple of special cases there that are sometimes a little more confusing. For number 11, again, I would just distribute that cubed power. Okay. Last thing for these notes, want you guys to do the odds on the back. Wait, do I want the odds? Hold on. No, I want the evens.
Oh, that's the one where that's like inside food and stuff.
Yeah, and it should be x. Should be x plus 5. Yeah, 2 on the outside is great.
When you you're factoring negative, you put it.
You gotta stay inside the sheet.
Okay. So it has to be inside the parentheses, because then it would also affect that -8.
You want it outside of the parentheses. Let's check. So, 5 left. Up 4 reflects over the x-axis. This is a vertical reflection. This is a y flip. Okay, that's why I don't like to say reflect over the x-axis, because it makes me think of the x direction. But you know, if you think about it, right, over the x-axis means up and down. So I don't like that. So negative on the outside, x plus 5 in parentheses, squaring that, plus 4. We do not have to FOIL that out. Don't do that unless you really want to. You might really want to. I don't. Okay, number 4, square root of x, up, 6 left, up 3, vertical stretch of 2. So 2 on the outside, minus 6 on the inside, plus 3 on the outside. Okay. 8 units to the right and reflect over the y-axis. This is an x flip. So what we need is cube root of negative x minus 8, like that. This is what we were just talking about. Or you can put that in there. You can make it negative x plus 8 if you don't want to have parentheses. I would go with this answer. That would be the easiest for me to make sure I do right. So the negative has to be factored out here. So reflective of the x-axis means we're going side to side horizontally. Sorry, reflective of the x-axis means up and down. So if I wanted to do reflect over the x-axis, oh whoops, that's eraser stupid. And the negative would be on the outside. Yeah. So everything on the outside is what happens to y. Everything inside is x. In this case, it would be pretty simple. And then quadratic function whose vertex is at 1, negative 4, that'd be x minus 1 squared minus 4. Absolute value function whose range is negative 3 to infinity, it'd be absolute value of x minus. Okay, now I want to mention something about number 2. Number 2, earlier in the year, there were some tricky questions on delta math that depend on their wording. So delta math will ask a lot of questions that look like number 2, except they'll say, then reflect over the x-axis, which means you take your parabola, you go left 5, up 4, and then you reflect it over the x-axis, which would look like that, which is not what this one is doing right here. If it said then reflect over the x-axis, what I would need is that x plus 5 squared plus 4 with a negative on the outside of all of that, basically taking all of that full shape and reflecting it. So this might be a little bit before we get to delta math questions like on the review, but be on the lookout for the wording. I'm not going to ask you this question for delta math, but definitely.